Hey guys, welcome to the South PyTech, the Python programming channel. And today are going to learn about the Pandas library and one of the famous module DataFrame. So basically what we are learning today we are learning about the basics of Pandas library and understanding the handling of the data by generating data into rows and column by means of series and list that we have already studied in our previous lecture, and then converting them into data frames. We also understand how to add or delete the columns and rename it as well. So as you all know, in the last video we have understand how to generate the series and list and end the arrays and converting them into data frame. So today we will exploring more functions and more things, like how we have to handle the data by adding, deleting, renaming the columns and generating the series and list and then converting them into the data frames. So what is pandas in Python? We have already studied this in our last video, and once again we will go through definition of the pandas. So pandas provide high level data structures and function designed to make a working with structure or tabular data that is fast, easy and expressive. The primary object in pandas are the data frame, a tabular column-oriented data structure with both rows and column labels, and series, a one-dimensional labeled array objects. So what we can do with the data frame using pandas make it simpler to do many time-consuming repetitive tasks associated with working with data, including data cleansing, data fill, data normalization, merges and joins, data visualization, static analysis, data inspection, loading and saving the data. And there are much more things in the pandas library that we will be studying in our upcoming and future videos, and we will playing many things with the data, with the Excel file by reading the Excel file, the CSV and the XLS format, saving them and taking the output of several Excel worksheet and spreadsheets. So what is data frames? So data frame is a two-dimensional level data structure with column of potentials, different type. You can think of it like a spreadsheet or SQL table that we normally use in database, or a dictionary of series object. It is generally the most commonly used pandas object like series data frame, and accept many different kinds of output like dictionary or one-dimensional, ND arrays, list, dictionaries or series, two-dimensional, NumPy, ND array, basically, and the NumPy, the numeric ND arrays, and the NumPy ND array of two dimension. So we have already studied this in our previous video. So over here we also be learning about the structure or record ND array and a series and another data frame. So you can see on my window how the data frame looks like by representing them. You can see the rows, the cells and the columns that are representing in the data frame or in the Excel sheet. So this is similar in the pandas, and we will be seeing how this Jupyter notebook shows the data when the data is converting into the data frame. Okay, so from dictionary of series or dictionary, we know we have to import the pandas library over here. So if pandas library is not installed in your system, so what we have to do, if you have PyCharm installed in your Windows, so just type pip install pandas. Okay, so you can see when I type the pip install pandas over here, so it says that the pandas library is already installed in your system. So in your case, when there will be no pandas library, when you will type pip install pandas, so the pandas library will be installing and showing the progress bar over here. This is your PyCharm console, and over here I have opened the terminal window, right? So over here you can write the pip install pandas right here. So let's move back to the Jupyter notebook, right? So over here we have imported the import pandas as PD and import numpy as NP. So let's execute this query and import these two pandas and numpy library over here. Okay, once your library has been imported, you can see over here we have written a dictionary. Dictionary always start with the curly bracket. We can see we have written the one. This is the column name, that is one, and we are generating a series, pandas series over here. We have already understood the series, how we have to generate this series in our last video. I will share the link over the top right corner on my video. You can watch that video from there. Okay, so over here you have written the series by opening this square brackets 1.0, 2.0, 3.0. This is in the float format, and you have already done the index abcd. Over here in the column 2, we can see we have generated another series of 1, 2, 3, 4 values with index labeling abcd. So let's execute and check, and now we will type the d over here. So we can see our series look like this. So this is the series before converting the series into the data frame. Now we have to convert this series into data frame. And how we will be converting? We have assigned a df data frame over here by typing df is equals to pd data frame. This will be converting the D series into data frame. So we have write a function over here, that is data frame, that will convert the D variable that we have assigned to the list, and it will convert into data frame, and we will see how it looks like. So let's run this query, and now we will be printing the data frame over here by typing df. So you can see now the above list over here, and over here when the series is converted into data frame, we can see the column 1. So in column 1 we have taken only series values 1, 2, 3, and with 3 index level abc, and in the column 2 we have taken the 4 values abcd. So you can see the NaN value in column 1 because d was not assigned over here. We are only having 3 single values in series. Now we can also re-index the data frame. We can see we have typed the pd data frame. Now we are taking the data with the same d that we have taken over here, and now we will type the custom indexing. We are starting now with d, p, and a alphabets, right? So we will run this query and we will check. Now the columns are the same 1 and 2, but the values are now arranged with the they are aligned with the index labeling that we have assigned over here, d, b, and a, right? So you can see the index are now reset or realigned with custom formatting or custom indexing. So it's starting with d, p, and a. Now over here we will replace the column names. So we can see we are again we have again typed the d data set, the d series over here, converting them into the data frame, and now the index are dba, and we are renaming the columns now 2 and 3. So first column will be renamed into 2 because it was renamed into 1. Now it will be changed into 2, and the 2 will be converted into 3. So this column name will be replaced, and we can see now the 1 column is replaced by 2 because in place of 1 we have written the 2, and in place of 2 we have written the 3. So you can see we have renamed the column names over here into the data frame. So we can see how a beautiful way we can change the columns name and align with them our data frame. So we have to use the column command over here. The column is equals to square brackets over here, and for index we have to type index is equals to dbna. So this is how the data frame align the index name as per the user requirement and rename the column names over here. Now the row and column labels can be accessed respectively by accessing the index and column attributes. Now we want to check the index name if the data is a big in a data of 50 to 100 column name, and we want to check. And if we want to check the index labeling as well, so we have to type the df dot index. We can see the index labeling abcde, and the data type is object. And if you want to know the column name, so we can type df column over here. Over here we can see index 1, 2 over here. So basically the new data frame was assigned with the df. It's showing the original df over here. So df represent abcd, the series, the data frame that we are converted over here, the data frame df. So this is the main data. The data is showing the column name and the index labeling over here, right? So df is the main data frame over here. Okay, now let's jump into the new topic from a list of dictionaries. We can see we have a new variable data2, and we are having a single list but having two set of dictionary that is represented by the curly brackets, and we have two columns A and B over here in the first set of dictionary, and we have three columns A, B, C with the values 5, 10 and 20 respectively, and this is a single list with two set of dictionary, and this is stored in the variable that is data2. So let's run this query, and now we can see how the data is represented before converting data into data frame. So this is the list with a set of dictionaries, and now we will convert this list into data frame. You can see we have assigned the data frame with a variable data2 because the list is stored in this variable, as you can see above. So let's run and check how our data frame looks like. Okay, so we can see three columns A, B and C as we know, and we have only two rows 0 and 1 with the values 1, 2 and not a number because C was not there in the first dictionary, but the C was there, the C column was there in the second dictionary with a value of 20. And now what we have to do, we will be renaming the index by typing the first and the second row by renaming it with the second. Let's run and check. We can see the 0 and 1 will be replaced by the first and second. So we can see the index label is now renamed by the first and the second string format as we have written over here. So we have to type the index to rename the index labeling by opening the square bracket. Now once again we have to rename or align the data frame according to the columns. So we will be renaming it A, B, and we assume that only two columns will be represented in this case of data2. So let's run and check. Okay, so we can see the first row of the data2 because data2 is the original data over here, and we want the column A and B only, right? And we don't want the C column, so only two columns are renamed or replaced by into the new data frame, that is data2, and we can only see only two data. So this is the original data, and this is not that one that we have renamed over here. So this one is over here, that is PD data frame that we have converted in the 17th line. Okay, now column selection, addition and deletion. We can see the original data frame df over here. So our original data was df, so we can see df data frame over here with the values of 1, 1.0, 2.0, 3.0 and 4. So once again I have written data frame over here. Let's execute and check. Okay, so now this is the original data that we have written already above. You can create the you can treat a data frame semantically like a dictionary of like indexing series object, getting, setting and deleting column works with the same syntax as the analogous dictionaries operations. Okay, so now if you want to obtain the values of df1, so we can see we have written the df over here, opening the square bracket, and this is the column 1, the first column. If we execute this query, we can see only the values of the first column, that is df1, right? So this is a very good way to obtain the values of the data frame 1. If I type data2 df2, so if I run, so we can see we will be having the values of df2 over here. We can see 1, 2, 3, 4. So this is how we can obtain the column values by typing the df square bracket double quotation and 1 the column name basically, and the data type is float64 and the column name is 1. Now we are generating a new column, that is df3, and df3 holds the value of the multiplication of df1 and df2. So we can see now we are multiplying two columns, that is df1 asterisk multiply by df2, and when these two values will be multiplied, so the new column will be generated, that is df3. So we are generating a new column into the data frame that is denoted by df, and we have written the column name. So if we run this query, and now we will check over the data frame how it looks like. So we can see the 3 column is now generated over here into our df, that is data frame, and this is the multiple of the first column and the second column, that is 1 and 2. So when 1 multiplied by 1, that is 1, 2 multiplied by 2, that is 4, 3 multiplied by 3, that is 9, and when there is no number, it is multiplied 4, so their value will be not a number because this is basically a 0. Okay, now we are raising a flag, we are generating a new column with the name of flag, and we want the true and false value, that is basically we called it boolean values, and we want to know if the condition make true, like we have given if the value of first column is greater than 2. So we are taking only column 1 and we want to know if they are greater than 2. So we assume that in column 1 we will getting the true value in the C row, right, where we can see index C. So if I run this query, and now if I want to see the third column, that is flag, and exactly that we assume that the value will be true when the condition makes 2, that is greater than 2. So the value of the column 1 that is greater than 2 is basically the 3. If I type is equals to 2, so we know that p value is equals to 2 and greater than 2 as well. So there will be now 2 true values, that is b and c. If I run this query once again, and now I check my data frame once again, so we can see the b and c values are now true over here because the condition satisfied the greater than is equals to value of column 1, that is df1. Now if we want to delete the column 2, so we have to simply type the function del, that is a command of the within the, this is basically the attribute of the data frame that we will tap over here, and we want to delete the column that is named 2. So delete del df, that is data frame, square brackets open 2, and if we run this query, and now we will check how the data frames look like by typing df, we will see the column 2 is now deleted or eliminated from the df data frame, right? So this is how nicely it works within the data and data frames over here. Okay, when inserting a scalar value, it will naturally be propagated to fill the column. So we can see we are generating a new column name, that is df data frame foo, right? We have written in double quotation, and the value is bar, so this is string value and that is the scalar value over here. So if I run this query and check how the new data frame it looks like, so the column foo that we have just generated, the value of the column is bar, and we can see the bar value is aligned to all index labeling a b c d e within the new column, that is foo. So this was about the scalar value if you want to insert some name or thing or any condition into the new column. So guys, you learned how to generate, delete, add and select the columns by doing some mathematical operation, by deleting them and by inserting some criteria into data frame. And if you want to raise flag true and false condition, if you want to delete some column, and if you want to insert some scalar value into data frame. So today you have also learned how to import libraries, how to insert the set of dictionaries, how to insert the list of dictionary, multiple dictionary, and you have learned about how to rename the index, how to rename the column, how to replace them, understanding the index and column name right over here, and converting them into the new column frame by aligning as per your custom requirement, by inserting the attributes of data frame of index and column attributes over here. So guys, hope you have enjoyed this video. It was a great understanding of data frame, and in upcoming videos we will be learning more about the data frame, importing the Excel file, the CSV, reading them, saving them, playing with the data frame, playing with the grouping, sorting, merging, concatenating, and many things in DataFrame. So guys, for an upcoming new video, I will request to kindly subscribe my channel, like, share, and do comment and give your feedback on my videos. How did you like, and if you want to understand what are the questions you are having. So I will share this Jupyter notebook in my description below. You can download this Python notebook and integrate with your Python console and Python PyCharm, and the link will be of the Google Drive. So thank you guys, take care, bye bye.